Okay, dear children, today we'll be doing numericals based on Newton's second law. So, this is the numericals which you have on your book. Okay, exercise number C. Okay, exercise number 3C. It's on page number 67 on my book, but I guess you all have a new book. So in the new book, the page number may vary, but you can just go in and around page number 67. Okay, so see, there are lots of numericals in your book. Okay, so in today's class we'll just do the four numericals. Okay, four basic numericals. Then in the next class, okay, in the next week we will do the remaining numericals. All right, so let's begin with the first question. Question number one, the one that you have on your book. The question, if I have to read the question, it says a body of mass 5 kilogram, okay, is moving with a velocity 2 meter per second. Calculate its linear momentum. So we are asked to find the linear momentum, and the two information given is 5 kilogram, that is the mass, and 2 meter per second, that is the velocity. Okay, so as I said you, we have four rules. So rule number one is to jot down the given information under the heading given. So given m, that is mass equals to 5 kilogram. All right, then you have velocity v equals to 2 meter per second. All right, and then we are asked to find the momentum. So rule number one is over. Rule number two, compare the units. Kilogram is the SI unit of mass, meter per second is the SI unit of velocity. So both the units are in same system, so no need to change any of the unit, okay, because they are in the same system. Rule number three, use the best relation. So the relation for linear momentum is mass into velocity, that is m into v. All right, so rule number three will follow. We know linear momentum equals to mass into velocity, so you will have 5 into 2, that is 10. Okay, and now since it is your linear momentum, unit will be mass into velocity, that is kilogram meter per second. All right, clear? So this is our solution. So here rule number 4, write the statement. So therefore its, okay, its linear momentum is 10 kilogram meter per second. So this is how you will do. It's very simple, very easy. Okay, it's just the direct application of the relation for linear momentum. All right, so this was your question number 1. Okay, now you pause the video and please note down this solution in your exercise copy. All right, okay, now we move to the next question. Now the next question that we are doing is question number 3. Question number 3, it says a force of 15 Newton acts on a body of 2 kilogram. Calculate the acceleration produced. So the information given here is 5 Newton. Now Newton is the SI unit of force, so this is your force. Okay, and here 2 kilogram. Kilogram is the unit of mass. So here force and mass is given, and with the help of force and mass you are asked to find acceleration. Okay, so let's follow the rules. First rule is to write the information provided in the question. So given 15 Newton. 15 Newton is force, so I'll write F. F equals to 15 Newton. All right, and mass is given, that is 2 kilogram. So from here you are supposed to find what? Acceleration. Okay, you are asked to find acceleration. Clear? So rule number 1, writing down the information given in the question, we have written that. Rule number 2, compare the units. Newton is the SI unit of force, kilogram is the SI unit of mass. So both the physical quantity are in same system. All right, now rule number 3, use the best relation. So we'll write we know. So we know from the Newton's second law, F equals to m a. Okay, so or you have to find acceleration, that is a, so we'll make a as the subject here. So when we make a as the subject, we'll get a equals to F divided by m, that is force by mass. So now let's put the values of force. The value of force given here in the question is 15, all right, divided by the value for mass given here is 2. So it's 15 by 2. So 15 by 2 means half of 15, that is 7.5. Now since this is acceleration, so you write the unit of acceleration, that is meter per second square. So this is our solution, and then you write the statement here, that is rule number 4. Okay, rule number 4 for the numericals in physics is to write the statement. So here you write the acceleration produced is 7.5 meter per second square. All right, so this is your question number 3's solution. All right, clear? So I hope everyone is getting this solution. Okay, now if you have any doubts, you can ask me. All right. Okay, now let's move to the next question, question number 6. The next question that we are going to do is question number 6. Clear? So question number 6. A force of 10 Newton, okay, force of 10 Newton acts on a body of mass 2 kilogram for 3 seconds. Okay, initially at rest. So the 4 information given here. This is number 1, this is number 2 information, this is 3rd information, and initially at rest. This is our 4th information which is given in the question. So we will write this under the heading given by following rule number 1. All right. So given F equals to 10 Newton. All right. Mass equals to 2 kilogram. T, that is the time, is for 3 seconds. So this force of 10 Newton is acting for 3 seconds. Okay, initially at rest. So initial velocity, okay, that is u. Initial velocity is denoted by small letter u, so that will be 0 because it is at rest. It is not moving, there is no motion. So if there is no motion, there is no velocity. All right, so we have jotted down the given information. Rule number 2 has to be followed now. Rule number 2 says compare the units. So Newton is the SI unit of force, kilogram is the SI unit of mass, second is the SI unit of time. So here we see that all the units are in same system, so no need to convert any of the units. All right, now rule number 2 is over. Now let's go to the question so that we can follow rule number 3. Number 1 is the velocity. You have to find the velocity. Understand? Now to find the velocity, let's assume that the final velocity, the velocity that we have to find here, the final velocity be v. Okay, let it be v. Is that okay? So let the final velocity, okay, be v. Is that okay? So rule number 3, use the best relation. So we know F equals to ma. Now why we are using this relation? Because to find the velocity we have to use the relation v equals to u plus at. This is the relation that we are supposed to use to find the velocity. Understand? We have initial velocity in the question, we have time in the question, okay, but we do not have accelerations. First we will find the acceleration by using the relation F is equals to ma. So from here we get a equals to F by m, that is 10 by 2, which gives us 5 meter per second square. So we got the acceleration from this relation. All right, now we'll use the best relation to find the velocity. So that is from the first equation of motion. Okay, so from first equation of motion, okay, v equals to u plus a t. or initial velocity was 0, so the value of u will be 0, plus acceleration, here we have just now calculated it is 5, and that force of 10 Newton was acting for 3 seconds, so the time here t will be 3. So here will give me 3 into 5 is 15, 15 plus 0 is 15, so 15 meter per second. Alright, so then you write the statement here for solution number 1. Alright, then we have one more question here, question number 2. It says change in momentum. Alright, change in momentum. Okay, so before we go to question number 2, now what you all do here is you pause this video. Okay, pause the video and you copy this in your notebook. Alright, clear? Okay, so now we'll do question number 2. Before that, let me make some space here, so I'll be just erasing this solution number 1. Okay, so when we are doing the sums, please read the question carefully. So some of you might not get the fourth information given here in the question. Okay, you might just see the force 10 Newton, mass 2 kilogram, and the time 3 seconds. But here one more thing is given here, that is initially. Okay, initially at rest. This is very important because this gives the idea of our initial velocity. Okay, so now let's go to question number 2. We are asked to find change in momentum. So change in momentum equals to final momentum minus initial momentum. Okay, so final momentum is given by the product of mass into final velocity, minus initial momentum will be given by mass into initial velocity. Alright, so here mass is 2 kilogram. The initial velocity, the one that we have calculated here, it is 15, minus mass is 2 kilogram into initial velocity is 0 because the body was at rest. So that is going to give me now 30 minus 0, okay, which 30 minus 0 will give me 30, and since it is the momentum, so the unit will be 30 kilogram, okay, meter per second. So this is my solution, and then again follow rule number 4 to write the statement for this solution. All right, so this is how we solve question number 6. So you see that the first two questions that we did today was bit easy. Now we are slowly proceeding to the ones, okay, which are a little bit tricky. I will not say it tough because it's not tough. It is a little bit tricky because the question has hidden information in it. All right, okay, so now we are moving to the last question for today's session, question number 9. So we will be now doing question number 9. This will be our last sum for today's class. All right, so now let me read the question. A force of acts for 0.1 second. So there is a force which is acting for 0.1 second. Now second is the unit of time, so this information here is for time. On a body of mass 2.0 kilogram. So it is 2 kilogram and kilogram is the unit of mass, so the information given here is mass. All right. Now initially at rest, so this is another information given here. Initially at rest means its initial velocity will be 0. All right. Then the force is then withdrawn. See, force they withdrawn gareko cha. All right, and the body moves with a velocity of 2 meter per second. So this is my final velocity, that is u. Initial velocity is 0 because the body says it is initially at rest. All right, so these are the information given here in the question. The question is telling us to find force. Now to find force, the relation has to be used as F is equals to ma. Force equals to mass into acceleration. So here mass is given in the question, but acceleration is not provided in the question. So first motive will be to find acceleration. So that is how we have to proceed to the solution. All right, so let's follow rule number 1. Let us jot down the given information under the heading given. Okay, t equals to 0.1 second, that is time. mass equals to 2.0 kilogram. Initially at rest means initial velocity is 0. Okay, then here you have another relation information, 2 meter per second, that is final velocity. So 2 meter per second is the final velocity. So these are the information given in the question. Rule number 1 over. Rule number 2, when you are doing numericals in physics, compare the units after you have assembled all the information given in the question. Second is the SI unit of time. Kilogram is the SI unit of mass. Meter per second is the SI unit of velocity. All the units are in same system, so no need to convert any units here. All right, now rule number 3, use the best relation. Now directly we cannot see, the question tells us to find force, but directly we cannot go and use this relation F is equals to ma to find force, because we do not have acceleration here. So our first motive will be to find the acceleration. Okay, so we'll use the first equation of motion. Okay, from first equation of motion, you know, v equals to u plus at, or v minus u equals to at. Okay, or a equals to v minus u by t. So this is our relation to find acceleration. Okay, so final velocity here is 2 minus initial velocity was 0. Okay, initially it was at rest, so initial velocity will be 0, and the time is 0.1. What is the time? 0.1 second. All right, then this will give me 2 minus 0 is 2 divided by 0.1. So when I remove the decimal, I'll get 2 divided by 1 by 10, which means 2 into 10. So this is going to give me 20 meter per second square. So I get a, that is acceleration, equals to 20 meter per second square. Meter per second square is the unit, SI unit of acceleration. Now we can find the force, because I have acceleration here. So now let me find acceleration here. So okay, now F equals to ma. What was the mass here? Mass was 2 kilogram into acceleration is 20, so that gives me 2 into 20, that is twice of 20 is 40, and the unit will be Newton. All right, so this is what is our motive behind this question. All right, so now follow rule number 4, that is you write the statement here. Don't forget to write the statement at the end whenever you are doing some sums. All right, I hope today's class was interesting and you have learned, okay, to solve the numericals from this chapter, laws of motion. All right, so that's it for today. Practice. You can practice the sums which we have not done, or with the numbers which we have skipped. All right, thank you so much, class.